Good day yet again, and we are back together. And right now we are looking at financial mathematics once again, and this time we'll be looking at compound interest. Okay, so if you haven't subscribed, please make sure that you're part of the family. And of course, you can always get in touch with us. Our email address is info@mlungisinkosi.co.za. Right, so we're looking at compound interest. Now, in our previous example, or in our previous lesson rather, we looked at simple interest. And when we talk about compound interest, first of all, we're talking about interest that is added onto a capital amount, or the primary, or in this case, the principal amount, together with the interest. Okay, so let's say for a compounding period, let's say in 1 year, the amount would have earned interest, but in the next year, what it does is that now the amount plus the interest earns interest. So you keep adding interest upon interest upon interest, right? So, of course, this is the most ideal case if you're trying to make money, okay? And that's why you'll find that most institutions work on a compound interest. Right. Now, first of all, just like we said, okay, when we look at A, that would simply mean this would be the accumulated amount. Once again, accumulated. Ooh, that word. Okay, so this would be the accumulated amount. Okay, and of course, this would be the principal amount, as we did say. And this would be obviously the amount that is charged, the initial amount that is used. Of course, that's our interest rate. Okay, so that is our interest rate. And of course, this is our period, which normally we talk about a year, right? Now, the most important thing when it comes to compound interest is that we can use this essentially on, when we talk about investments. Okay, we can talk about investments over here, investments. Okay, we can talk about loans as well. Okay, we can talk about, many other, applications wherein compound interest is actually, used, right? What I just want us to do is to talk about in the normal sense. So in the normal sense, what we normally do is say, well, N would be when we are compounding per year. This is per annum, right? If our compounding period is per annum. But there are also other instances where we find that. Now, and I want to show you quickly where we find that the compounding period is different, meaning we can compound in 1 year, so meaning that we can add in the interest amount, every year, or we can have interest that is accumulated over, per quarter or per month, or even per day for that matter. So what it does is that it changes our formula just a little bit. Okay, so A is equals to P, 1 plus I over M. We'll talk about M just now. Okay, and in this case, this would be N multiplied by M. All right, now what is M? M would be, in this case, the compounding period. All right, now if in this case the compounding period, let's say for instance, let's say M is the compounding period, or in this case the number of times that interest is added per year, right? So if, let's say, they say to you interest is compounded semi-annually, so that's semi-annually, or as the Americans would say, semi-annually. Okay, semi-annually. In this case, then we know that the value of M is equal to 2. But also we can have, the compounding period, in this case, they say quarterly, Okay, so if it's quarterly, then we know that M would be equal to 4, right? So remember, there are 4 quarters in a year. So in that case, it means not only do you divide the interest rate by 4, but you also multiply, by 4 for the for N, the number of years. In that case, your investment is in place, or whatever the case may be. Okay, right, and of course we can have monthly. Okay, so if it's monthly, then we know that monthly M is equals to 12. There are 12 months in a year. And of course, we can also have daily. You can have weekly, which is, there are 52 weeks in a year, or you can have daily, which in that case, I'm trying to remove this and write it nicely. So daily, that would be, in this case, M would be equal to 365. Of course, we are considering just a normal year, all right? But of course, in a leap year, that would be 366. So just keep that in mind, right? So what I want us to do is to look at some examples that are going to apply this principle, and let's see how we are going to proceed with this. All right, so let's take again the case Kabelo, and we say Kabelo invested 120,000 with a bank, and the bank pays an interest at 9% per annum, right, which was compounded. Now, obviously, that's our clue to know that we are talking about compound interest, right? They say if she does not withdraw the interest and leaves it in the account, right? So in this case, she will not be making any withdrawals, so she will just let the money grow, right? They want to know, calculate the accumulated amount in the at the end of 12 years. Now, we know in this case that we are compounding what? Annually. So if we're to look at the M value is 1, so that means that we can use just our normal A is equals to P 1 plus I to the power N formula, right? So we want the accumulated amount, so we are answering A in this case. But what is our principal amount? We know that we are investing 120,000 rands, right? So in this case, that would be 120,000. Okay, and 1 plus, now what is our interest rate in this case? They told us that it's 9% per annum, right? So in this case, remember once again, to get the interest rate, we always divide by 100, okay, percent, right? Means just division by 100, so that would be 0.09. So we know that our I is 0.09, okay, to the power N. So in this case, N would be the number of years. They wanted this in 12 years, so this will be to the power of 12. And of course, you're going to put this in your calculator, 120,000, okay, which would be 1 plus 0.09 to the power of 12. Okay, and I get an amount of 337,519 and 77 cents. If you remember from our previous video, when we're using simple interest, we use the very same amount at the same interest rate. And you remember, I think it accumulated to about 249,600. So you can actually see that with compound interest, you get a much better return than you would when it comes to simple interest, So in this case, obviously, that is why most banking institutions would prefer to use compound interest instead of simple interest, right? So the next question, they say, calculate the total interest earned in this case. So we want to know the amount of interest that has been earned. So remember once again, what we did was that we said, well, look, we don't want the interest rate. There's a difference between interest rate and the interest that is earned. So interest that is earned, that's in rands, and interest rate, that's in percentage, right? So in this case, we're going to say, well, the interest that is earned would be, the accumulated amount, right, minus the principal amount. So in this case, so that would be 337,519.77 and minus, and I'm going to subtract in this case. Remember that our principal amount was 120,000 rands, right? So if I say minus 120,000, I get an amount of, it's a very good amount, very good interest in this case that you would have earned over that period. That's 217,519.77. So think about it. In that period of time, Kabelo would have actually earned more interest than even the principal amount that she would have initially invested. Okay, right, now let's take another example. I hope this has been really, really clear. Let's take another example. Right, in our second example, so we're looking at 45,000 rands that is deposited into a savings account, right? They say calculate the value of the savings after 7 years, right? They say if the interest rate is 14% and it is compounded quarterly. Now note in this case that they are changing the compounding period. So it means that because it's quarterly, we are compounding 4 times a year, right? So what we're going to do is we want to find out what the accumulated amount is. But remember, because we are not compounding annually, in this case, it means that we're going to consider our formula I over M in this case, and this would be N multiplied by M. Okay, so we know our principal amount would be 45,000, okay, and that would be 1 plus. Now our interest rate, once again, this would be 14%, as we did say, that you're going to say 14 divided by 100, that would be 0.14. But remember, we divide because our M value is 4 in this case. So that would be quarterly, that's 4. And in this case, we've got 7 years, but remember that we are compounding 4 times a year. So that would be 7 times 4. All right, now, and we hit those calculators. Of course, I know you're going to assist me on this one. So that's 0.14 over 4, right? And I'm going to actually to the power 7 times 4, and I get an amount of 117,000. Okay, so I get 117,907.74. Okay, so that's 117,907 rands and 74 cents. Now, I want you to please note in this case, look at the, how much that amount has accumulated to in about a space of 7 years, right? So it does actually, they say compound interest is one of the greatest miracles in life. So yeah, you want to definitely make sure that you earn compound interest. All right, now, if you wanted to calculate the amount of interest that you have earned, in this case, of course, you can always once again say interest. That would be accumulated amount minus principal amount. And of course, you can take that value, 117,907.74, and we subtract it from that 45,000 just to gain perspective, Remember, we initially deposited 45,000, and you'll see that what it does is that it earns 72,907 and 74 cents in interest. So this would be the interest amount that would be accumulated. All right, so I hope that it's sinking in, and I just want to take one last example that we're just going to do together, and so that we drive the the nail home. All right, so looking at our last exercise, they say Tony invests 30,000 into a savings fund for a period of 8 years, right? They say the total growth of the fund amounts to 65,000. So in this case, they are also giving us the accumulated amount, right? They say calculate the interest rate. Note now we are calculating the interest rate, not the interest, right? Per annum compounded annually, that would yield the same return. So in this case, we are considering compound interest. So now what do we have? They have given us the accumulated amount to be 65,000. But remember, 30,000 was initially invested. So we're going to say, well, we know we invested 30,000 there, right? We want to find out what the interest rate is. And we know that N would be 7 years, right? No, 8 years actually. So that would be 8 years. Okay. They did say to us that we're compounding annually. So in this case, we're going to consider our normal compound interest formula, right? Because we are compounding annually. So we know that that 65,000, that's our accumulated amount. Our principal is 30,000, okay? Plus 1 plus, we want the interest rate in this case, and this would be to the power 8. Now, of course, we need to solve here. What we're going to do is that we're going to divide by 30,000 first, okay? And please do not round off just yet. Okay, so we just leave that as 30. Remember, this cancels that 30,000 there. Those two cancel. And in this case, now, we have an exponent of 8. So what do we need to do to remove that exponent? It means we must take the 8th root. Okay, so you're going to go into your calculator and look for the 8th root. Okay, that looks a little bit clumsy. Okay, so we're going to look for the 8th root. So in this case, what we have there, we've got 65. Now, of course, we can cancel that. That would be 65. 65 over 30. Okay, is equals to 1 plus I to the power 8. As I did say, we are taking the 8th root, but what we do on the left, we have to do on the right. Okay, so of course that 8th root would take that away. So we've got 1 plus I on this side. Now quickly, let's do that. In your calculator, right, you take the 8th root. So I would have 8 over there, and I would have 65 over 30. Okay, and I get a value of 1.1014. But then I subtract this 1 if I take that to the other side. So minus the 1, I get a value of 0.1. So I get I is 0.1015. Let's just round it off to that. But remember, interest rate must be measured as a percentage. So what I still need to do is multiply that value by 100. And so what I get is an interest rate of 10.15%. Okay, so that's if it was compound interest. Okay, right. The next question, I hope that made sense. So they say calculate the simple interest per annum that would provide the same return. So remember, we considered in the previous example that it would have been compound interest, but this time they say, well, what would be the simple interest rate that would give us the same return? So remember, that's 1 plus I times N in this case. So we've got 65,000. We've got 30,000 on this side. We've got 1 plus, we want the interest rate, but we know this is multiplied by 8 this time around. Okay, once again, we're going to divide both sides by 30,000. Okay, okay, that would cancel that. So we can actually just be left with 65 over 30, which is equals to 1 plus 8i. I times 8 and 8 times I are exactly the same thing. Okay, so if we take 65 divided by 30, okay, and we subtract the 1, okay, when we take the 1 to the other side, we subtract it. So I'll just say minus 1. Okay, I get 7 over 6, right? So in this case, right, so I get 7 over 6, and so 8i would be equal to 7 over 6, but then we divide both sides by 8 once again, so that cancels that to get the interest rate. So I'll divide that by 8 again, and I get a value of 0.1458. But remember, interest rate, you multiply by 100, and so that would give us 14.58%. And do you see, once again, ladies and gents, you would need to actually apply a far much bigger interest rate if you were to use simple interest as opposed to compound interest. And I hope that makes the issue of compound interest quite clear for you, and the difference between simple interest and compound interest. Otherwise, I'll see you guys again next time. Please don't forget to subscribe. Don't forget to share and like. Thank you so much. See you again next time. Sharp, sharp.